So which kind of transformations can we use? The literature is not going to give us a good summary of types of transformations. So here's a summary table that I have developed from reading papers. Whenever I'm reading a paper and I notice that transformations have been used, I've got a summary. And so depending on which type of data can help us to determine what might be a suitable transformation to use. So if we have counts, numbers of disease or insects, especially cases when we have a small number of very large values or possibly even a Poisson distribution, till accounts. Common transformations tend to be log x or the natural log of x. If our data contains a lot of zeros, we cannot take log or a natural log of 0, so we can add, take the log of x plus 1 will allow the transformation to be calculated. Magnitude of this value, if we have data, say, in the range of 0 to 100, we might add 1. If our data tends to be smaller in the range of 0 to 10, we might add 0.01. We simply want some number here that's small in magnitude to the range of our data that allows this calculation to be made without having an invalid calculation. Area data, such as leaf area, harvest and flowering data. Establishment counts, where we have some zeros, we might use the square root of x. Where we have a lot of zeros, we might use the square root of x plus 0.05, for example. We have a lot of proportion data where we're presenting data from 0 to 100%, especially when we're getting at the upper range around 100 or at the theoretical lower limit near a 0. Botanical composition is very common. If we're reporting the percentage of white clover in a pasture mixture, we often will find arc sine x or arc sine square root of x are common transformations for these kind of data. Equally, if we have lots of zeros, we can simply transform by adding 0.05 to avoid having a lot of zero values in our results. So different kinds of data, and now the reality is there's no perfect transformation for a particular type of data. We can simply do a little bit by trial and error, and we might go to one of the commonly used transformations. But we try a transformation, rerun the ANOVA on the transform data, test the assumptions again. If we meet the assumptions with the transform data, then the transformation's been successful and we can proceed with that analysis. Sometimes if we are unsuccessful, instead of square root, we could try cube root. I've even gone so far as trying the fourth root for certain data types. Just got to give you a heads up here. There are some data that no amount of transformations is going to be able to fix those. I have probably 4 or 5 cases over 30 years have found some data that just will not transform. That presents us a problem because if our data is simply not going to transform to any of those assumptions, we really should question whether ANOVA is a suitable analysis option for those data, and we may need to look at other options for analyzing that data outside from ANOVA. We'll look at that option later in the semester. Most cases I've seen in the literature, as a last resort, we will use non-parametric statistics. So we always have some kind of option, but most of the time when we see non-parametric statistical methods used in the literature, it has been in the case where none of the options for transforming the data was satisfactory. So how do we show this in publications? In publications, we should always show the untransformed means when we're describing these in the text, or we're showing tables of data. It's going to be very confusing for readers to be seeing data that includes means that have been transformed. They're almost impossible to interpret without back transforming. So our tables of data should show those untransformed means. In the statistical methods, we should have a description of which tests, which assumptions failed, or which assumptions were corrected, and which transformation was used. Now, in some cases, you may go through a series of 2 or 3 different transformations. You wouldn't necessarily need to show or describe all of the transformations that you tried, simply sufficient to say that you failed the transformation, failed the ANOVA assumptions, you made a transformation, and that transformation was successful, will be sufficient for the purposes of reporting. Now, the literature is variable on whether you should show the untransformed or the transformed analysis. In your dissertation, we typically have more liberty to show all of the steps. You might describe the untransformed results and the transformed results. And if they agree, whether they're significant or not significant. The process is relatively simple if the untransformed analysis and the transformed analysis agree. Going back to our gray leaf spot data, with the untransformed data, we got a significant result, but we have the suspicion from failing the assumptions on ANOVA that that interpretation may be invalid. However, having done the transformation, the ANOVA still remains significant. So our interpretation is very simple. Whether we're based on the untransformed data or the transformed data, our conclusions are in agreement. Probably we didn't look at this, the ranking of the treatments or the use of the LSD values. We should base the LSDs on the transformed data analysis, which may show a different separation of treatments than for the untransformed data. If we have the case where the untransformed data was significant and the transformed data becomes non-significant, then we have a problem, because we can only show the results from the transformed ANOVA, and that would be a non-significant result. That's kind of unfortunate, because then we are limited on what we can say with our data, even though we might want to refer back to the untransformed data that was significant. It's very likely that it's a type 1 error because of the violations of the assumptions of ANOVA. I've never seen a case where the untransformed data was non-significant and it becomes significant with the transformation. That may occur. I've never heard of or seen an example where that were possible. In our publications, we always need to state the data were checked for conformity to the assumptions of ANOVA. Even if it passed the assumptions, we should always state that we did that, the rigor of that analysis, we checked for conformity, and that our data met the assumptions of ANOVA. It's very comforting to the reader, and to know that the data analysis was done with sufficient rigor, that you checked for those assumptions of ANOVA and that no adjustments were necessary. So there's quite a lot to report here, but in many cases we might do a lot of analysis but simply have very little to report in for that. Later in the semester, we will be looking at some manuscripts and looking at their statistical sections. And in general, the literature is very poor on how transformations are used and how the assumptions are tested. And maybe a quarter to a third of papers will actually report this detail of information. So next week, we will be going on to a new topic, covariance. And in the recitation this week, we will try some examples using SAS and R to test our assumptions and to make those transformations.